All right, so now that we've talked about the structure of acids and bases, we recognize weak acids and weak bases. We can do Ka and Kb and pH and all that stuff. Now we have to look at, well, when we put an acid and a base together, H plus from the acid goes with the OH minus from the base and makes water, but we also get some other ionic compound, some salt that gets created, okay? And these salts aren't always neutral. So what we want to look at now is the acidic basic nature of salts, and we have the notes. As we are going to that, we can look at this right here. Just okay. Just make it a tad smaller. I got a glare, so I'm going to keep it low. Okay, but you can just kind of see on the pH scale here, coming down to 1, right here. Okay, you got vinegar, carbonated soft drinks, tomato juice. Okay, acid rain coming way down here. Normal rain is less than 7 because of carbon dioxide making carbonic acid in the rain. You can see the basic things. Just some common household, just to give you an idea on pH.
Milk is an acid.
Milk is the slightly acidic, yeah.
Lactic acid.
Okay, but I mean it's barely. Okay, that's just just kind of give you a little bit again of how it affects y'all. All right. So the acid-base properties of salt. It all has to do with the strength of the conjugate acids and conjugate bases of the salts that we're combining. So if I take HCl and I combine that with NaOH, what am I going to make? NaCl and water. That's going to be aqueous, and I'm going to have water, HOH, liquid. So what type of acid is HCl? This is a strong acid. What about NaOH? Strong base. So technically, this is going to this is the conjugate acid. This is the strong base. This is the conjugate. And then the Cl minus is the conjugate of the HCl. Well, if you have a strong acid, what does that mean about the strength of the conjugate? Weak. So both of these ions, when I put NaCl into water, it's going to dissociate into Na plus water. And it's going to dissociate and be Cl minus plus water. But because these are both very weak conjugates, they are not going to be strong enough to pull the hydrogen off of the water. And as a result, they're just going to float around and be spectator ions. So this is going to make, there's no reaction. So this is going to be a neutral salt. Strong plus strong is going to make a neutral salt. Now, if we change it up and we put acetic acid, HC2H3O2, and NaOH. Now what am I going to get? I'm going to get Na sodium acetate, NaC2H3O2 plus HOH. And this again will be aqueous because it's sodium. Now what type of acid is acetic acid? It's a weak acid. But this is still our strong base. Okay? So now when I'm looking at the conjugates, this again is going to dissociate the Na plus water. It's going to still do no reaction. This is still weak. It's a spectator. Sodium's always a spectator ion. It just floats around and doesn't react with anything. But this acetate, C2H3O2 minus, it's from a strong base, okay, it's from a weak acid, which makes it a stronger conjugate base. So it can actually react with water, and if it's a base, what does it do with hydrogens? Accepts them and produces which ion? What's the ion that's going to make it basic? OH minus. So it's going to accept the hydrogen and go back and make this plus the OH minus. Now y'all remember, it's the presence of H plus that makes an acid acid. One of the things that confused me when I was first learning chemistry is, but I made the acid. How come this isn't acidic? Because it's the together. It's when the hydrogens ionize is what makes it an acid. Here it's molecular. It's the presence of the OH minus increasing this is what makes it basic. Okay? So it's the formation of this. Now notice again, it's the hydrolysis of the water. So sometimes when you put a salt into water, one part of the salt is going to react with the water and hydrolyze the water and produce either an OH minus or an H plus. In this case, it's a weak acid, strong base. So since we're producing OH minus, what type of salt is this one? Basic. It's a basic salt. So, it's a little bit confusing here, so just bear with me. A weak acid, strong base. Strong winds, it's going to be a basic salt. But it's the part that came from the weak acid that's actually going to react with the water, because it's going to be the stronger conjugate base. Okay? So, if whatever you're mixing an acid and a base together, the stronger one is what the salt's going to be. So weak acid, strong base, basic salt. Strong acid, weak base, acidic salt. Strong and strong just makes neutral. And we're not going to worry about weak and weak, because then you have to compare Kas and Kbs, and we just won't have to go there. Okay? So if I put HCl plus NH4 OH, what's that going to make? NH4Cl plus HOH. And this is ammonium, so it would be aqueous. Okay, so now I have a strong acid. But what about NH4OH? It's a weak base. That's the basic form of ammonia. So what type of salt is this going to be? Acidic. An acidic, strong winds. It's going to be an acidic salt. But which part of the NH4Cl is actually going to react with water to create the acidic solution? The NH4 plus or the Cl minus? NH4. The NH4 plus, the part that came from the weak, is going to be a stronger conjugate than the thing that came from the strong. So the Cl minus, the NH4 plus, will react with water. And if we're saying it's acidic, what do acids do with hydrogens? If this is an acidic salt, okay, is the H plus going to want to accept another one and go to NH2, NH5, 2 plus? No. It's going to want to get rid of that plus and go back to NH3. So we'll get NH3 plus H3O plus. Now the Cl minus, that's the part that came from the strong. When it reacts with water, it's not strong enough to do anything. There's no reaction. So we just get the acidic salt. So the thing that comes from the conjugate of the strong is always a spectator ion. The conjugate of the strong is always a spectator ion. It's the conjugate of the weak that's going to react with it. So if I'm taking the conjugate of a weak base, the conjugate is going to be what type of substance? An acid. If I'm taking the conjugate of a weak acid, the conjugate is going to be basic. That's the part in a salt that's going to react. Okay? So in your notes, you can kind of ignore this part here. This is the weak acid, weak base part here. Okay, so you can just ignore that. So this person goes through and gives you, look at the acid, what it's coming from. But just let's look at some examples down here at the bottom. Okay? So if you have the notes right there, you're looking, you ask yourself the question, okay, so first off, in sodium acetate, what's my positive thing, what's my negative thing? What's my positive thing, what's my negative thing? Sodium's positive, acetate's the negative. So what base, where did sodium come from in making this salt? NaOH. Plus HC2H3O2. Now you don't have to write this out, but this is what you think mentally. So what type of base is NaOH? Strong base. What type of acid is acetic acid? It's a weak acid. So what does that make this? It's going to be a basic salt. Okay? Now, why? Let's write the equation. What's going to react with water and how is it going to react for a basic salt? What's it going to make? What's going to react with what do I write for an equation?
The acetic acids that react with water.
This?
Or the acetate.
This is what I'm putting into water. So it's going to be the acetate. It's going to react with water. And again, we're saying it's a basic salt. So what is the acetate going to do with hydrogens? Accept the hydrogen from water and produce a hydroxide ion. So we're going to make, the hydrogen's going to donate, we're going to get HC2H3O2 plus OH minus. It's always the part that came from the weak, the conjugate of the weak. And that's good. You just need to let it go. Okay, I mean, it is what it is. Let's make our time wise, use our time wisely while we have it. All right. So what's my positive thing on B? NH4. NO3 is my negative. So the positive always came from the base. The negative always comes from an acid. So what base is this? NH4OH. Is that going to be a strong base or a weak base? A weak base. And what's the acid? HNO3. And is that a strong or a weak acid? So this salt is going to be acidic. Okay? Acidic. So, but which part now, this is, again, you're not putting these into water. This is what you're putting into water. So which part of this is going to react with the water? The NH4 plus. And since we're saying it's acidic, what is it going to do with hydrogens? And we're going to make NH3 plus H3O plus. So take a second now and just look at this one and tell me, if you don't say it out loud, just think about, is it going to be acidic, basic, or neutral? And if it's acidic or basic, which part of this is going to react with water, and write the equation for it. So is it acidic or basic or neutral?
Acidic.
How do I know? What this is going to make came from which base?
ALOH3.
Aluminum hydroxide, right? ALOH3. So we just say weak base. H2SO4 is a strong acid. Therefore, I know this is going to be an acidic salt. Okay? That's all you have to do. Just put an OH on the front, put an H on the negative one. Whichever one is stronger is what the salt's going to be. Now, which part is going to actually react with the water? The Al. Now, you don't. The Al2 is there, but we can just say Al. It's not a diatomic. Aluminum is going to react with water. Okay? Well, with water again, I always write it HOH. And that'll make, and it's really the Al3 plus, aluminum hydroxide plus 3 H3O pluses. So we need a 3 here.
Maybe just H plus.
If I'm getting 3 OHs, I'm going to get 3.
Yeah.
3 OHs, and then the 3 H's onto. Oh, I see what you're saying. It's unbalanced. So do I need 6 waters?
Just make it the H plus.
Just make 3 H plus. That works. There'd be plenty of waters around if the reaction was in water, and they'd end up being H3O pluses, but to balance it, it makes it easier that way. To be able to determine whether it's acidic, basic, or neutral, you just look at, in your brain, you just think, what base did the positive thing come from, which acid did the negative thing, the stronger one wins. Okay? Then it's the part that comes from the weak that's actually going to react with the acid. Now, if I want to calculate the pH of one of these, we're going to do it just like any other reaction, but we have to understand this. For any conjugate acid-base pair, Ka times Kb is going to equal Kw. So in other words, if you have the acid, the Ka of the acid times the Kb of the conjugate base is always going to equal Kw, which is a constant 1 times 10 to the minus 14. All right? So if I want to find out, okay, so let's just say here on A, what is the pH of a 0.1 molar sodium acetate solution? Okay? And they give you Ka of HC2H3O2 is equal to 1.8 times 10 to the minus 5. All right? So that's what I'm given. So the first thing I have to do is say, okay, well, is this going to be an acid or a basic salt? We just did it right here. Basic, right? So I know that my equilibrium is going to be the C2H3O2 minus plus water is going to go to HC2H3O2 plus OH minus. So that's my equation. So I have 0.1 molar of this is my initial. 0 and 0. The change is going to be minus X plus X plus X. But I need the value, since this is a base, I need the Kb. So the Kb of C2H3O2 minus is going to equal 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5.
Someone do that for me, please. I used to know what it was.
.6 times 10 to the negative 10.
So that's Kb for my acetate ion. So that's going to equal my X times my 0.10 minus X. But we're going to negate the X again because it's going to be way smaller. So X is equal to my OH minus is going to equal what? Somebody solve that. Just take the square root of this times 0.1.
7.5 times 10 to the negative 6.
So then the POH is equal to the negative log of that, which is equal to 5.9,
1.
5.1.
Yeah.
So therefore the pH is equal to 14 minus 8.9.
Yeah.
So the only thing that's different with a salt is, number one, we have to determine whether the salt is acidic, basic, or neutral. Now, if it's neutral, it's just 7. Neither one's going to react with water, and it's just going to be 7, so there's nothing really to do. If it's acidic or basic, you figure out, first off, is it acidic or basic? You write the equation for how it's going to react, the part that's going to react with the water. If you're given the Ka and you need the Kb, or you're given the Kb and you need the Ka, you have to use this expression right here. And then you do everything else exactly the same. Okay. So, NaF, acidic, basic, or neutral. This is the next page of the notes. Acidic, basic, or neutral? NaF.
Acidic. Basic. Oh no, basic.
NaOH, strong base, HF, weak acid. So it's going to be a basic salt. Which part of this, the Na plus or the F minus, is going to react with water?
F minus.
The part that comes from the weak. So it's going to be F minus plus water, HOH. And again, if you're saying it's basic, what's it going to do with the hydrogen? Accept it and produce the hydroxide ion. So it gives HF plus OH minus. Now, this is the base. They give me the Ka of the acid. So how do I find the Kb of F minus?
1 times 10 to the negative 14 divided by the 7.2 times 10 to the negative 4.
Okay? So that's going to come out just 10 to the minus 11 something.
1.4.
And that's going to equal X times 0.3 minus X. right? I'm just doing the ice table in my head, but it's just like we've been doing on all of them. You negate the x, we take the square root, so x, which is equal to OH minus, is equal to the square root 0.3 times 1.4 times 10 to the minus 11. That's that shortcut again that we said we can go straight to.
2.1 times 10 to the negative 6.
So POH, the negative log, 2.1 times 10 to the minus 6, which I am going to suspect is 5.7.
Yeah.
Therefore, the pH is 14 minus 5.7, 8.3. Okay, so the only thing you have to, when you notice that it's a salt, you have to determine it's acidic, basic, or neutral salt. Then you determine if they give you the Ka of the acid or the base, the conjugate's always, you just got to do this step. Then the setup is exactly the same from everything else.
Oh, would they ever ask it if it was a neutral salt?
No, because it's just going to be pH of 7. So you just say salt is neutral, pH equals 7. There's nothing else. Let's see if you can do the next one on your own. And just for the record, I would not worry about the third example problem. I don't like the aluminum. The way they react with water is crazy. You would never have to be able to write the equation for that. And we've already talked on page 21, 22, we've already talked about the Lewis acids and bases, so this really concludes this section of the notes. getting the answer that's posted? All right, so is this an acidic, basic, or neutral salt? Acidic. So which part is going to react with the water?
NH4.
NH4 plus. Since it's acidic, what's it do with the hydrogen?
It loses one. Donates.
Donates it. What ion gets produced on the right-hand side always? Hydronium ion, okay, because we're producing H+. So we're going to make NH3, it donates the hydrogen, and we're going to get H3O+. An acidic salt is not going to produce OH-. An acidic salt produces H3O+. A basic salt produces OH-. And if you go back and look at the notes, there's a little thing about this on page 20 or 19 that you can kind of look at and try if you're struggling with that a little bit. So I have 0.1 molar of this, but this is an acid. This is Kb. What do I need? Ka. And it doesn't matter if it's capital A or little a, it's just 50-50. Ka, 1 times 10 to the minus 14, divided by 1.8 times 10 to the minus 5. We know that that's 5.6 times 10 to the minus 10. So we just did it over here. So that's going to equal my x times 0.1 minus x. So x is equal to H3O plus, which is equal to the square root 0.1, 1.8 times 10 to the minus, well, 5.6 times 10 to the minus 10. And H plus equals
7.5 times 10 to the minus 6.
So therefore the pH is equal to the negative log 7.5 times 10 to the minus 6 is equal to 5.13. Are we good with that? That's kind of going to be important when we start talking. The next thing we're going to talk about is buffers. It'll be Monday. We'll start talking about buffers because buffers are going to be a weak acid with the salt, the conjugate of its weak acid. So it's going to be a weak acid in the conjugate base. So we're going to need to know the Kas and the Kbs and kind of go back and forth on that. And buffers is one of the more challenging concepts, but we're going to do it in a day or two and just get through it. Okay? Now, you have 12 minutes remaining. You can get most of that sheet done that I just gave to you in that 12 minutes. Okay? Because I think only the last one is a problem. Happy Friday. Have a great weekend and go Jags.